In this video, we're going to talk about number systems. The first number system that you need to be familiar with is the decimal system. Now, when you hear the word decimal, what do you think of? Think of the prefix deci. What does that mean? When I hear the word deci, I think of 1/10 of a whole. For example, there's 10 decimeters in 1 meter. I also think of the word decade. A decade corresponds to 10 years. And so deci is associated with 10. And in fact, the decimal number system is a base 10 system. And so what this means is that there's 10 different numbers in the decimal system. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's a total of 10 numbers. Now, this system is used for everyday counting. For example, 12 or 36 or 468. We use the decimal system to represent numbers, and it works pretty well. Now, the next system that you need to be familiar with is the binary system. So when you hear the prefix bi, what do you think of? Bi means 2, and so the binary system is a base 2 system. It's very useful for computers or any type of digital circuits. There's only 2 numbers here, 0 and 1. In a typical digital computer, 0 means off, 1 means that the system is in the on state. Next, we have the octal system. And when you hear the word octal or octa, what do you think of? I think of an octagon. An octagon is basically a polygon with 8 sides. So octa means 8. So the octal number system is a base 8 system. So there's 8 numbers that we can use in this system. The first being 0, and then 1, 2, 3, 4, 5, 6, 7. So that's a total of 8 numbers, including 0. Next, we have the hexadecimal system. Now, what is meant by the prefix hexa? Hexa, think of a hexagon. A hexagon has 6 sides, and so hexa means 6. We know decimal corresponds to 10, and so 6 plus 10 will give us 16. Therefore, the hexadecimal system is a base 16 system. And so the numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have all 10 numbers in the decimal system, but we also have 6 letters. And so those letters are A, B, C, D, E, and F. Now A corresponds to 10 in the decimal system. B in the hexadecimal system corresponds to 11 in the decimal system. C is 12, D is 13, E is 14, F is 15. So that's a total of 16 numbers, including 0. Now let's talk about how we can convert a decimal number to a binary number and into an octal and a hexadecimal number using the technique called successive division. So let's say we have the number 348. If you see a subscript 10, that means it's in the base 10 system, which means it's a decimal number. So the first thing you want to do is take 348 and divide it by 2. So if you type that in, you'll get exactly 174. So it's 174, remainder 0. Next, take 174 and then divide that by 2. So that's exactly 87. So it's 87, remainder 0. Next, if we take 87 and divide it by 2, we're going to get 43.5. So it's 43, remainder 1. But first, let's write it like this. So this 43 gets transferred here. And then to get the remainder 1, you multiply 2 by 0.5, and that will give you the remainder 1. I'm going to write my answer like this for now. Now, if we take 43 and divide that by 2, that's going to be 21.5, which is 21, remainder 1, and then we need to take 21, divide that by 2, so that's 10.5, which is 10, remainder 1, and then 10 divided by 2 is exactly 5, so 5 remainder 0, and then 5 divided by 2 is 2.5, so 2 remainder 1, and then 2 divided by 2 is exactly 1, so 1 remainder 0, and then 1 divided by, I'm running out of space here, 1 divided by 2, that's 0.5, so 0 remainder 1. What we have on top is the least significant bit, and this here is the most significant bit. Now you can find your answer just by looking at all of the remainder values, which is here. And so that's the binary number that's equivalent to 348. So you need to read it from the bottom to the top. So the answer is 1, 0, 1, 0, and then 1, 1, 1, 0, 0. So that's how we can convert a decimal number into a binary number using successive division. Now let's convert this number into an octal number in the base 8 system. So if we look at the last example where we converted 348 into a binary number, we were dividing it by 2 because binary, it's based on the base 2 system. Bi means 2. The octal system is based on the base 8 system. So instead of dividing it by 2 and collecting the remainders, we're going to divide it by 8 this time. So 348 divided by 8. That's going to be 43.5. So this is 43 remainder. Now to find the remainder, multiply 8 by 0.5. So 8 times 0.5 is 4. So it's 43 remainder 4. Next, take 43 and divide it by 8. And this will give you 5.375. So it's 5 remainder, and then multiply the 8 by 0.375. 8 times 0.375, that will give you 3. Next, take the 5 and divide it by 8. Now, 5 is less than 8, so we can say that 8 goes into 5 0 times with a remainder of 5. But if you do 5 divided by 8, you're going to get 0.625. And so the 0 gets transferred here. And then if you multiply 8 by 0.625, you should get this number, the original number that you started with, which will go here. So this is the most significant digit, and above we have the least significant digit. So we're going to read it from the bottom to the top. So 348 base 10 as a decimal number is equivalent to 534 or 534 in the octal system. And so that's how you can convert a decimal number into an octal number using successive division. Now let's talk about how to convert the decimal number into a hexadecimal number using successive division. So let's use the same number, 348. Let's convert it to a hexadecimal number. Now the hexadecimal number is basically a number in the base 16 system. So this time, instead of dividing by 2 or 8, we're going to divide by 16. So if we take 348 and divide it by 16, this will give us 21.75. And so that's 21 remainder. To find the remainder, multiply 16 by 0.75. So 16 times 0.75, that's 12. So it's 21 remainder 12. Now let's take 21 and then let's divide that by 16. So 21 divided by 16 is 1.3125. And so we have 1 remainder. Now let's multiply 16 by 0.3125. And that's going to give us 5. So it's 1 remainder 5. Next, take 1 divided by 16. Now we know 1 doesn't go into 16, so 16 goes into 1 0 times with a remainder of whatever you see here. In this case, a remainder of 1. And so we're going to read it this way. So we have a 1, a 5, and a 12. Now 12, because it's larger than 9, we need to convert it to a letter. So remember, 10 corresponds to A, 11 corresponds to B, and 12 corresponds to C. So it's 1, 5, C. So therefore, we could say this. 348 in the base 10 system is 1, 5, C in the base 16 system. And so that's how we can convert a decimal number into a hexadecimal number using successive division.